So I have been busy today doing a bit of rewiring, more below the surface here, but what I am eventually going to do is take this whole board out and rewire it sometime when I could get a nice warm night, because I don't want to take the solar panels offline at all. I want to have them running as much as possible, and what I'm planning to do is have all the wires behind the board, so the only things in front of the board will be these three blocks where I can connect stuff up to, and then it'll just be bolted through and very strong connections will be made. So underneath here what's happened is I've got a current shunt here. That's the new current shunt, the 100 amp 75 millivolt one for the amp meter. So basically any reading on the meter, just double it and then you'll get the correct reading, because it's a 50 amp meter and I've just changed the shunt over. So I've ordered DIN rail as well, so I'm going to have some circuit breakers in here. I've already got the main one. That there's a contactor which came out of the Mitsubishi Outlander battery, and there's a bit of a problem with it. Sometimes it sticks, so when I switch that contactor off, sometimes it doesn't actually switch off, it sticks a bit, and that's just for the inverter, which I've just mounted up in there. But that sticking problem is a real issue. I would have thought if it had been a high quality Omron contactor it wouldn't do that, but I think it may be because with the capacitors and the inverter being discharged and then this connecting them, it's a huge burst of current and then it maybe slightly welds the contacts inside. But I'm going to plug the car in now and charge it off these batteries. So I've been measuring the water it's produced. I've ordered a, well unfortunately I've lost it, but I was at 700 earlier. But I've ordered a DIN rail watt meter which will become part of the system. So that should start registering power soon. £1,250 watts. And here's what's showing up on the amp meter. So it's 27 amps, so that's about that's well over 60 anyway. I'm not sure if that shunt is going to be entirely accurate, because I don't have a watt meter really that's going to be able to confirm the accuracy for me. I could maybe somehow connect one up, but I'd only be able to run it for maybe a few seconds because it will get pretty hot. So I must be pulling about 54 amps, so that's not too bad if that's correct. So just checking to see if the shunt is getting warm. It's getting rather warm unfortunately. I've calculated I'll lose about 10 watts over the shunt when you put 100 amps through it. I'm not sure exactly, but it's about that. You lose a few watts anyway. And these cables here do get slightly warm. They're 16mm squared cables. They could really do with being bigger, but I don't think it would. I don't think it's going to matter too much. They're not roasting. They get a bit warm and that's it. The orange cable going into the circuit breaker, it stays cold all the time, and it's quite a bit larger. It just came out of the battery as well. It was just one of the high voltage cables. So what I'm going to do is discharge it to 25.9 volts, which is about 3.7 per cell. And the reason I'm doing that is I just like to keep them at a low state of charge while I'm away, just in the extremely unlikely event that anything serious goes wrong. It means there's not as much energy there to cause trouble, and I only have them at a higher state of charge when I'm around. And the reason I've got that copper bus bar at the negative there is mainly because the cable going to this charge controller and those connector blocks is not long enough, and it just sort of gives me a better connection to because the posts on the battery aren't actually long enough to have all these connections on them. Oh, and as well, the inverter cables are not long enough. So the contactor I can control just using, I've got the Raspberry Pi up the other end of the shed that I can use to control that. And I'm just using Web.io Pi. I can use that to switch this inverter on now, or the grid tie inverter, but the grid tie inverter is not going to be getting used very much anymore. I'll be having everything on a DIN rail, which is just a rail type for mounting circuit breakers, and also have a DIN rail mounted watt meter which will measure AC watt hours coming out of there, and that's so I can put it on the spreadsheet and keep a track of how much energy I produce. What I'm going to do is wire this voltmeter directly to the battery, and what that will do is give me a more accurate reading of voltage drop. I had my multimeter on the battery the other day there, or it was today actually. I had the multimeter on, and when the grid tie inverter was pulling about 25 amps, the voltage on the battery was only dropping 0.06 volts, and that's just because the internal resistance is next to nothing. So I just want to do a voltage drop test. I'm measuring it direct at the battery terminals. So we've got 25.92 and we're pulling 35. Yeah, we're pulling 70 amps, so let's take the 70 amps away. Yeah, the voltage drop is very, very small, so that's pretty good. So we'll just start the car charging again. So there we go. I'll be stopping the car charging soon anyway, because I only want to discharge this to 3.7 per cell. Now I've done a bit more. I've put this relay on here, and this is the charge controller, which I'm just using as a low voltage cutoff. So that means that when the batteries get to about 3.85 per cell, no, not 3.85, it's 3.65 roughly, what will happen is this will cut everything off, and that basically means it won't allow the grid tie inverter to be switched on, or the power inverter under the work surface, until the voltage rises back up again. I think it's to about 3.9 per cell. So that's just an extra little bit of safety there. These here are just my 3 spare cells. I'm just discharging them just now to about storage voltage. I'm going to do a video on their internal resistance, and I'll do a discharge curve and things like that too. But that's it. The only thing left to do is take the entire panel out and do a nice rewire on it to make it all neat and tidy.